Hello everyone, welcome to IIT-JAM in Chemistry tutorial number 32. This is lecture number 10 of the physical chemistry chapter, liquid state. Viscosity of liquid is the subtopic which is being discussed in the last 3 lectures. As a continuation of the Poisson equation which was derived in the last lecture, here in today's lecture we are going to learn how the relative viscosity is measured with the help of Ostwald's Viscometer. Let's recall equation number 13a, which is the mathematical form of the Poisson equation, and the equation is eta equals to h rho g pi r to the power 4 t over 8 lv, where eta is the viscosity of the liquid, h is the height of the liquid column, rho is the density of the liquid, g is gravitational acceleration, r is the radius of the capillary of length L through which v volume of liquid is passing through at time t. So, if equal volume of 2 different liquids are allowed to flow through the same capillary under similar conditions, then their corresponding viscosity coefficients should have the expression eta 1 and eta 2 as. Here, before describing the expression of eta 1 and eta 2, let's discuss which are the variables and which are the constants in this equation. Eta is definitely a variable because 2 different liquids are taken. H is constant because the same liquid column is used, so the height of the liquid column must be constant. Rho must be different because the liquids are different. G is constant, pi is constant, R must be constant here because you are using the same capillary. For the same reason, S is also a constant, and since you have taken equal volume, look at this term, equal volume, so this capital V is also constant. Only T is the variable because 2 different liquids would take 2 different times. So the expressions of eta 1 and eta 2 should be like that. Eta 1 is equal to h rho 1 g pi r to the power 4 t1 over 8 lv, and eta 2 is 8 rho 2 g pi r to the power 4 t2 over 8 lv. Look, the constant terms are colored in blue, while their variable terms are colored in red, and their ratio is eta 1 over eta 2 is rho 1 t1 by rho 2 t2. Look, the constant terms have been cancelled by each other. This is equation number 14. Now, the viscosity of a liquid is determined with respect to water, which is known as the relative viscosity. The absolute viscosity of water has been very accurately determined so far at different temperatures. So with the help of that data, we can easily measure the viscosity of other liquids. Okay, so this is the Ostwald's Viscometer, and this is a U-shaped cylindrical tube having 2 bulbs at 2 different levels. So let's describe this instrument. The instrument is a bent hollow glass tube. It has 2 bulbs at 2 different heights. It has 1 capillary mount on the inner wall of the vertical tube. The position of the capillary is just below the upper bulb. The upper bulb has 1 upper mark and 1 lower mark. So look at this. This is a hollow cylindrical glass tube and bent in the shape of English capital letter U. It has 2 bulbs. This is 1 bulb, this is another bulb, but look at the heights of these 2 bulbs. Their levels are different. This is the upper bulb, this is the lower bulb. This upper bulb has 2 marks. This is the upper mark, this is the lower mark, and just below this bulb a capillary has been mounted in the inner wall of that glass tube. So you have to take a fixed volume of liquid, say 20 ml, 15 ml or 25 ml, with the help of a pipette. So insert the liquid or pour that liquid within this bulb. It will settle here, it will store here, it will be stored here, and from this point you have to suck it, and when the lower meniscus touches this upper mark, then just release the pressure, the suction, release the suction, then liquid is now falling through this capillary. After some time t, this lower mark of this bulb will be touched and the overall time is recorded. So what is the principle? Relative viscosity of a liquid with the help of equation 14 can be determined by Ostwald's Viscometer. That means you have to take 2 different liquids. Okay, and you have to use that equation number 14. Rho 1 eta 1 by eta 2 equals to rho 1 t1 by rho 2 t2. So the data eta 1, if it is the viscosity of the reference liquid, it is known to you. T1 is the time required for the reference liquid, say it is water, and ρ1 is the density of water, which is a known parameter from the literature. And you have to determine with the help of picnometer the density of the experimenting liquid, which is ρ2, and this way, by taking or by recording the time taken for that liquid is T2, you can easily find out the value eta 2. Okay, so a liquid of known viscosity is used here as a reference liquid. So here most of the time water is used as the reference liquid. Okay, and it has a wide range of viscosity which has been accurately determined at different temperatures. Say at 298 Kelvin it is 1.005 centipoise. At 303 Kelvin it is 0.9957 centipoise. And you know that the SI unit of viscosity is Pascal second, and the CGS unit of viscosity is poise, and we know that 10 poise is 1 Pascal second. Poise is dyne per centimeters into second, and 100th time of a poise is centipoise. So this is in the unit centipoise. Okay, a certain volume of reference liquid is first taken inside the viscometer, that is water is taken, a certain volume, maybe it's 15, 20 or 25 milliliter with the help of a pipette. Then it is drawn up to the upper mark of the upper bulb by suction. So you are sucking it, and the reference liquid is then allowed to fall through that capillary up to the lower mark, and the time T1 is recorded. Same is done with the experimental liquid, and at the time T2 is recorded here. Density of the reference liquid ρ1 is known at that particular temperature. It is available in the literature at different temperature, different densities of water. Density of the experimental liquid is determined with the help of a picnometer, that is the specific gravity bottle. And the viscosity coefficient of the reference liquid is also known because it has been accurately determined at different temperatures. Two data have already been given here. By putting these values in question number 14, we can easily calculate the viscosity coefficient eta 2 of the experimental liquid, and these are the formula. Okay, so the formula of ρ2, first density measurement. Okay, so what is the density of the experimental liquid? Suppose W1 is the weight of the empty bottle, W2 is the weight of the bottle plus water, and W3 is the weight of the bottle plus the experimental liquid. So what is the weight of the liquid? Now W3 minus the weight of the empty bottle, that is W1, and that of water is W2 minus weight of the empty bottle, that is W1. So if these masses are divided with volume V, then the densities are obtained. So what is the ratio of the density? The ratio of the densities is W3 minus W1 by V over W2 minus W1 by V again. So 1 by V is in the numerator, 1 by V is also in the denominator. So these 1 by V's are cancelled. So only the masses only left behind. So this is actually the ratio of the densities, which is ρ2 by ρ1. And if this ρ1 from the denominator, if you take it to the right hand side by cross multiplication, then it will come to the numerator here. So this is the expression of density. Okay, so this way density is measured, and the working formula equals from equation number 14, just by cross multiplication, eta 1 is taken to the right hand side, and by putting the value, all the 5 parameters are now known to all of you. So eta 2 is determined. Okay, so this ratio eta 2 by eta 1, this is known as relative viscosity. We are going to discuss in the next lecture about this. Okay, so that's all for today's lecture. Thank you. Have a nice day.